Circles. We talked a lot about polygons this chapter and have ignored circles. Circles, we're going to talk about area, sector, circumference, and arcs, starting with distance around a circle. The distance around a circle is famously known as the circumference equals pi times the diameter. The diameter is what goes all the way through the center of the circle. So here's the center. All the way through, we call that d, the diameter. All the way through the center of the circle is the diameter. And pi is that famous number 3.14. And if you go onto YouTube, you can find all sorts of great videos where people will recite tons of values of pi. It's actually rounded to 3.14. It's closer to 3.14159. And I strongly encourage you to find the Dance of the Sugar Pie Fairy so you can hear it to a whole ton of digits more than you ever knew. But I'll let you do that YouTube search on your own. Where I'm going to blow your mind is if you write the number pi backwards as a mirror image, you get pi. Whoa. All right, so another thing we can do, though, is not just find the circumference or distance around the circle, but we might only be interested in part of the way around. Part of the way around a circle, we call this an arc. An arc is found using a proportion. We take the arc measurement over the degrees is equal to the circumference measurement over 360. So first we find the circumference, and then we set up this proportion in order to solve for the arc. Degrees on the bottom, measurements on the top. So here we've got this 5 centimeter piece on an 80-degree arc. We're going to find out how long that arc would be. And first, to do that, we need to find the circumference. And the circumference is equal to pi times the diameter. Pi is 3.14, or at least that's how we'll estimate it in this class, times the diameter. Now remember, the diameter goes not just to the center, which the 5 does, but it has to go all the way to the other side. So the entire diameter here is going to be double the 5, or 10 centimeters. So the circumference is 31.4 centimeters. But we want to find the arc. So we'll set up a proportion. The arc we don't know, but we know it's an 80-degree arc, is equal to the circumference of 31.4 over the 360 degrees that make up the entire circle. Well, we know how to solve a proportion by multiplying the diagonal. So we have 360 times x equals 31.4 times 80, which is 2,512. To get the x alone, we divide both sides by 360. And x, the arc length, off my calculator, is 6.98 centimeters. So almost 7 centimeters, 6.98 centimeters on that arc distance. So the distance around, it's called the circumference. Part of the way around is called an arc. But the piece we're missing still is the area, how much fills up the circle. The area of the circle is found by the formula pi r squared, which we all know is silly because pi r round and cake r squared, but we'll go with it. R is the radius from the center to the edge. That is the radius. It's half of the diameter. Similarly, we can find part of the area, maybe a slice of pizza or a slice of pie. That's called a sector. Lots of vocabulary in geometry. To find a sector, we use a very similar proportion. We put the sector over the degrees is equal to the area over the 360 degrees. The area is on top, the degrees on the bottom. So here I've got a circle. 12 meters is the diameter, and we want the sector area of 115 degrees on there. So first we need to know the area of the entire circle. So area is pi r squared. Pi is approximately 3.14. R is the radius. The radius just goes from the center to the edge, and the 12 meters goes all the way across. So we need to find half of 12, which is 6 meters. So the area is 3.14 times 6 squared, or 36 times 3.14, which would probably be better to write it, keep everything in order. 3.14 times 36. So the area of the entire circle on my calculator is approximately 113.04 square meters. But we don't want the entire circle. We just want the sector. And the sector is only 115 degrees of it. So we're looking for the sector x over the 115 degrees is equal to the entire area, 113.04, over the 360 degrees. And then we can solve the proportion by multiplying the diagonal. 360x is equal to, and the numbers are going to get big, so don't be afraid to grab a calculator. 115 times 113.04 is 12,999.6. Divide both sides by 360. And x, our sector area, is equal to 36.11 square meters. So we've got 36.11 square meters in that sector. Now, as you're working with your formulas for areas of a circle and circumference of a circle, quite often we have to use what we know to get what we need to solve the question. So for example, this question says, I know the area of a circle is 19.63 square inches. It wants to know the circumference. What we know is the area. Area is equal to pi r squared. But we know the area. The area is 19.63. We also know pi is 3.14. What we don't know is the radius. But we can solve this equation quite quickly. Divide both sides by 3.14. And the radius squared is equal to 19.63 divided by 3.14 on the calculator is 6.25. The opposite of square is to take a square root. So we're going to take the square root of 6.25 on my calculator. And r, my radius, is 2.5 inches. But the question didn't ask for the radius. The question asked for the circumference. And circumference is equal to pi times the diameter. Well, if we know the radius of the circle is 2.5, the diameter all the way across is double that, or 5 inches. So the circumference is 3.14 times the 5 inches. And when we do that, we get a circumference of 15.7 inches. And I said 15.7. There we go. 15.7 inches. So sometimes with our problems, we're going to have to take what we know and work to get what we need in order to answer the question at hand. But this introduction video took a look at areas and sectors, circumferences and arcs, 2 simple formulas, and then proportions to find the other 2. Take a look at the assignment and practice a few of these, and let your instructor know if you still have any questions.